In this video, we're going to talk about how to use tree diagrams to solve probability problems like this one. So we have a bag that contains 8 red marbles and 12 blue marbles. And 2 marbles are selected with replacement. So part A, what is the probability of selecting 2 blue marbles? So let's begin by drawing the tree diagram. So during the first selection, there's 2 options. Either a red marble is selected or a blue marble. Now, if we select a red marble in the first try, in the second try it can be red or it can be blue. Now, if we select a blue marble on the first try, on the second try it could be red or it could be blue. So thus we're going to get 4 possible outcomes. If we go in this direction, the first outcome is red and then red. If we go in this direction, the second outcome is red and then blue. Or if we go in that direction, it could be blue first and then red. Or if we go in this direction, it can be blue and then blue. Now let's write down the numbers. So what is the probability of selecting a red marble? There's a total of 20 marbles. 8 are red, 12 are blue. So the probability of selecting a red marble on the first try is 8 out of 20. And we could reduce this if we divide by 4. So this becomes 2 over 5. So that is the probability of selecting a red marble. Now the probability of selecting a blue marble, there's 12 blue marbles out of 20. And if we reduce the fraction, this will be 3 over 5. Now, the problem says with replacement. So what that means is once you select a red marble or a blue marble on the first try, when you make your second selection, you're going to put back the first marble in the bag. So you're still going to have a total of 20 marbles. So the probability of selecting another red marble is still 8 out of 20 or 2 out of 5. And the probability of selecting a blue marble is still 12 out of 20 or 3 out of 5. Now let's calculate the probability that corresponds to each outcome. So what is the probability of getting a red on the first try and another red on the second try? Now just to review, whenever you hear the word and, when you're connecting two events, you need to multiply. When you hear the word or, you need to add. So we need to multiply these two numbers. 2 over 5 times 2 over 5, that's going to give us 4 over 25. So the probability of selecting a red marble and then another red marble is going to be 4 over 25. What about red and then blue? So we need to go in this direction. Thus we need to multiply 2 over 5 by 3 over 5. And that's going to give us 6 over 25. And for blue and then red, it's also going to be the same thing. That's 6 over 25. And then the probability of selecting 2 blue marbles is going to be 3 over 5 times 3 over 5, which is 9 over 25. Now, if we add up these 4 values, it should give us 1. 4 plus 6 is 10, plus 6, that's 16, plus 9, that's 25. So we get 25 over 25, which is 1. And 1 corresponds to 100%. So now that we've completed the tree diagram, we can now answer the questions in this problem. So what is the probability of selecting 2 blue marbles? So the answer is right here. The probability of selecting 2 blue marbles is 9 over 25. Now, if you want to turn that into a decimal value, you can type that into a calculator. 9 divided by 25 as a decimal is 0.36. And if you multiply that by 100, you get 36%. So there's a 36% chance of selecting 2 blue marbles. So that's the answer for part A. Now, part B. What is the probability of selecting at least 1 red marble? So think about that. How can we find the answer? Looking at the 4 possible outcomes, which ones contain at least 1 red marble? So this one has at least 1 red marble, and the same is true for that one and this one. So in order to calculate the probability of selecting at least 1 red marble, what we need to do is add up these 3 values, because it could be RR or RB or BR. And remember, the word or, when dealing with probability, means that you need to add the individual probabilities for each event. So it's going to be 4 over 25 plus 6 over 25 plus another 6 over 25. And so that's going to be 16 over 25, which is 0.64 or 64%. Now, there's another way in which you can get the same answer. And it's important to understand that the probability of selecting at least 1 red marble is equal to the probability of not selecting 2 blue marbles. So understanding that, you can use this formula. So the probability of getting at least 1 red marble, let's say R is equal to or greater than 1, it's equal to the probability of not getting 2 blue marbles, which is 1 minus the probability of getting 2 blue marbles. So the probability of an event occurring is equal to 1 minus the probability of that event not occurring. So this is going to be 1 minus 0.36, which is the answer that we had in part A. The probability of getting 2 blue marbles was 9 over 25, which is 0.36. And 1 minus 0.36 is 0.64, which gives us 64% again. So that's the other way in which you can get the same answer. Now, let's move on to the next part. Part C. What is the probability of selecting a red marble first and then a blue marble? So the answer is just 6 over 25. And as a decimal, that's 0.24, which corresponds to 24%. So that's it for part C. Now, part D. What is the probability of selecting a red marble and a blue marble? Think about that. So I'm going to give you a minute to think about how to do it. Feel free to pause the video and tell me what you think the answer is for part D, or at least write it down and play the video to see if you have it right. In part C, the order of selecting the 2 marbles matter. In part D, the order does not matter. And that's the key difference between part C and D. So for part C, it has to be red first and then blue. So that's only RB. But in part D, we just need a red and blue marble. So that could be RB or BR, because they both contain a red and a blue marble. So we need to add these 2 values. 6 over 25 plus another 6 over 25, that's 12 over 25, which is 0.48 or 48%. So there's a 48% chance of selecting a red and a blue marble, but there's a 24% chance of selecting a red marble first and then a blue marble. So be careful with questions like that. Now let's work on this question. A bag contains 5 red marbles and 10 blue marbles. Sally selects 2 marbles without replacement. What is the probability of selecting 2 red marbles? So let's begin by making our tree diagram. So the first 2 options that we can get is either going to be a red marble or a blue marble on the first try. Now if we get a red marble on the first try, then we can get either another red or a blue, just like before. And if we get a blue on the first try, we can get a red on the second try or another blue marble. So the first option could be RR, and the second option could be RB. The third outcome will be BR, and the fourth outcome BB. Now, what is the probability of selecting a red marble? So we have 5 red marbles and 10 blue marbles. So it's going to be 5 red marbles out of a total of 15. And if we divide both numbers by 5, we can reduce it to 1/3. Now, the probability of selecting a blue marble on the first try, there's 10 blue marbles out of 15. And so we can reduce this fraction to 2/3. Now, what about the probability of selecting a red marble on the second try? Now remember, this problem is without replacement. So what does that mean? It means that when Sally selects the first marble, she doesn't put it back in the bag before selecting the second marble. So during the second try, we're not going to have a total of 15 marbles. We're going to have a total of 14 marbles because she took out one. So in the first try, she took out a red marble. So now we have 4 red marbles and 10 blue marbles. So this is what is known as dependent events, because the second event depends on the first event, whether she took out a red or a blue. In the last problem, there were independent events. The second event did not depend on the first event. Now, if she takes out a blue marble, what just happened there? If Sally takes out a blue marble on the first try, there's going to be 5 red marbles left over and 9 blue marbles left over for the second try. So as you can see, the amount of marbles, or rather the type of marbles that we'll have, is dependent on the first event. So over here, what is the probability of selecting a red marble during the second event? So we have 4 red marbles out of a total of 14. So it's 4 out of 14. And if we divide both numbers by 2, we can reduce that to 2/7. So on the second try, the probability is 2/7 that a red marble will be selected. What about a blue marble on the second try? Particularly this blue marble. So we have 10 blue marbles out of 14. If we divide 10 and 14 by 2, that will be 5/7. Notice that these two numbers add up to 1. That's 3/3. And these two numbers add up to 7/7, which is 1. The probability of an event happening, or this event not happening, which is equal to the probability of that event happening, always adds up to 1. Now let's look at the other side. What is the probability of getting this particular red marble after we get a blue marble on the first try? So now we have 5 red marbles out of a total of 14. So it's just 5 out of 14. Now the probability of selecting a blue marble on the second try after getting a blue marble on the first try, that's going to be 9 blue marbles out of 14. So now we can answer the questions. Part A. What is the probability of selecting 2 red marbles? So the probability of getting a red marble on the first try is 1/3. And then the probability of getting another red marble on the second try is 2/7. So we need to multiply those two numbers, and this becomes 2/21, which is like 0.095238. So we could say it's approximately, there's a 9.5% chance of getting 2 red marbles. So that's the answer for part A, or the approximate answer. Part B. What is the probability of selecting a red and a blue marble? So does the order matter here? Are we looking for red and then blue, or are we looking for red, blue, or blue and red? All we need is just a red and blue marble. So this is going to be the answer. So the probability of getting RB or BR is going to be the sum of the probabilities of those two events. So let's write PRB, the probability of getting R and then B, plus the probability of getting B and then R. So let's start with this one. This is going to be 1/3 times 5/7. And then for this one, it's going to be 2/3 times 5/14. So this is the probability of getting RB, and this represents the probability of getting BR. So this is going to be 5/21. Just multiply across. And for the second part, 2 times 5 is 10. 3 times 4 is 42. But we can reduce that. If you divide both numbers by 2, 10 divided by 2 is 5. 42 divided by 2 is 21. So that becomes 5/21. These two, it turns out they have the same probability. And so that gives us 10 out of 21, which is 0.47619. So this is going to be approximately 47.6%. So there's a 47.6% chance of getting a red and a blue marble. Number 3. A bag contains 3 blue marbles and 7 red marbles. Megan selects 3 marbles with replacement. What is the probability of selecting at least 1 red marble? So let's begin with a tree diagram. As always, we have 2 options. On the first try, she can select a red marble or a blue marble. And on the second try, remember there's 3 selections. She's selecting 3 marbles. So on the second try, it can be red and blue again. And after selecting blue, it can also be red and blue again. Now, there's a third try, or a third selection. So it can be red or blue. So notice the possibilities. If we go in this direction, it can be R, R, R. Or if we travel in this direction, it can be R, R, and then B. The next one is going to be R, B, R. And then the fourth option is R, B, B, and then the fifth option is B, R, R, and then it's B, R, B, and then we have B, B, R, and finally the last option, B, B, B. So we have 8 different outcomes. And the way you go about calculating that is that we have 2 choices, red or blue, and there's 3 selections. We're choosing 3 marbles. 2 to the third is 8. So in the first selection, there's 2 options, red or blue. In the second selection, 2 options, red or blue. So you multiply by 2. In the third option, there's 2 options, red and blue again. 2 times 2 times 2 is 8. And so that's how we get 8 different outcomes. Now, let's answer, well, first we need to put down the probability values. So we have 3 blue marbles, 7 red marbles. The probability of getting a red marble is 7 over 10. And the probability of getting a blue marble is 3 over 10. Now, this is with replacement, which means that Megan is going to put the marble back in the bag. So we're always going to have 10 marbles, 3 blue marbles and 7 red marbles. So every time she's selecting a red marble, the probability will be 7 over 10. And every time she selects a blue marble, the probability will be 3 over 10. So what is the probability of selecting at least 1 red marble? So let's identify all the outcomes that contain 1 red marble. So that would be these 7 outcomes. So now we can add up the probability of each of these 7 events occurring, or we could say that the answer is equal to the probability, it's 1 minus the probability of this occurring. So the probability of selecting at least 1 red marble is equal to the probability of not getting 3 blue marbles. So let's calculate the probability of getting 3 blue marbles. It's 3 over 10 times 3 over 10 times 3 over 10. So basically, this is going to be 3 over 10 raised to the third power. 3 times 3 times 3 is 27. 10 times 10 times 10 is 1,000. And we need to get common denominators here. 1 is the same as 1,000 over 1,000. 1,000 minus 27 is 973. So this is the answer. As a decimal, it's 97.3%. I mean, as a percentage. As a decimal, it's 0.973. So there's a 97.3% chance of selecting at least 1 red marble. Now let's move on to part B. What is the probability of selecting at most 2 blue marbles? So let's identify all of the outcomes with at most 2 blue marbles. So what does that mean, at most? Can we have 3 blue marbles? Nope, the maximum is 2 blue marbles. So this contains 2 blue marbles. This one too. This doesn't exceed 2 blue marbles. So that qualifies. What about the first option? Does that qualify? Well, let's think about it. At most 2 blue marbles. So that means that the maximum number of blue marbles is 2. So we could have 2 blue marbles or anything less. We could have 1 blue marble or even 0 blue marbles, because that's still less than 2. So that option must be included. So once again, we're looking for the probability of getting these 7 outcomes. which is equal to 1 minus the probability of getting 3 blues. So the answer for part B is the same as that for part A. It's going to be a 97.3% chance. The probability of selecting at least one red marble is the same as the probability of selecting at most 2 blue marbles. In both cases, this outcome is eliminated. Now let's move on to part C. What is the probability of selecting no red marbles? This is the only option that has no red marbles. So we're just looking for the probability of getting all 3 blue marbles. So it's just going to be 3 out of 10 times itself 3 times. So that's 27 over 1,000, which as a decimal, that's 0.027. And as a percentage, there's a 2.7% chance of this event occurring. Now, I'm going to add a question to this. What is the probability of selecting 2 blue marbles? It has to be 2. Go ahead and try that. That is exactly 2 blue marbles. So we need to highlight all the options with 2 blue marbles. So that's this one. That's one. Here's another one. And here is the second one. But not this one. So we need to find the probability of getting these 3 events, and then we're going to add them. So the probability of getting a red, and then a blue, and then a blue is going to be 7 over 10 times 3 over 10 times 3 over 10. So 3 times 3 is 9, 9 times 7 is 63. So that's 63 over 1,000. Now for this one, it's going to be the same, because the probability of getting a blue is 3 over 10, for a red is 7 over 10, and then 3 over 10 for another blue. So that's still going to be 63 over 1,000. And the same is true for this one too. To get the first blue is 3 out of 10, the second blue is 3 out of 10, and the red is 7 out of 10. So we're going to add up 63 3 times, or 63 times 3, that's 189. So it's 189 over 1,000, which is 0.189. So there is an 18.9% chance of getting exactly 2 blue marbles. Now let's work on this problem. There are 5,000 cars in a certain neighborhood. 40% are black and 60% are white. 75% of the black vehicles are sedans, while the rest are SUVs. 20% of the white vehicles are SUVs, while the rest are sedans. What is the probability of selecting a black sedan at random? So let's begin. There's 5,000 cars in this neighborhood. So out of that, 40% of those cars are black, and the other 60% is going to be white. So what is 40% of 5,000? 40% of 5,000 is basically 0.40 times 5,000. And so that's going to be 2,000. So there's 2,000 black cars. 60% of 5,000 is 3,000. So we have 3,000 white cars in the neighborhood. Now, 75% of the black vehicles are sedans. So let me create another tree diagram. So this will be 75%, which means this part has to be 25% because it has to add up to 100. So this is for the sedans, and the other 25% has to be SUVs. So 25% of 2,000 is 500, and 75% of 2,000 has to be 1,500, because these two numbers have to add up to 2,000. Now for the white vehicles, 20% are SUVs, which means the other 80% has to be sedans. Now 20% of 3,000, that's 3,000 times 0.20. That's going to give us 600 SUVs. And 80% of 3,000, or 3,000 times 0.8, that's going to give us 2,400 white sedans. So now we can answer the questions. What is the probability of selecting a black sedan at random? So how many black sedans do we have? So this is where the black sedans are. There's 1,500 black sedans in the neighborhood out of 5,000 cars. So it's going to be 1,500 divided by 5,000. And so as a decimal, that's 0.3, which is 30%. So there's a 30% chance of selecting a black sedan at random. Now there's another way in which you can get that same answer, and it's by multiplying these two percentages. So if you multiply 0.4 by 0.75, it will give you 0.3, which is equal to 30% if you multiply 0.3 by 100. So that's the second way to get the answer. Now, part B. How many white how many white SUVs are in this neighborhood? Now, we already have the answer to that question. It's 600. With the percentages, what you could do is you can start with this number, 5,000, and then multiply that by 60%, or 0.60, and then multiply that by 20%, or 0.20. And that will give you 600 white SUVs. And so that's another way in which you could use tree diagrams to solve probability-based problems. And that's basically it for this video. Thanks for watching, and don't forget to subscribe to this channel.